So, okay. So, expressions compute values. Good job. Statements do. They accomplish something. They perform some task. Okay. They change things generally. Okay. Okay. Yes. Okay. Well, comments we described. Okay. So Java statements. Java statements do something. They affect some change, and generally they're going to do something like change what's shown on the screen, change someone's income level, make someone older, change their state, connect to people, otherwise weren't connected, that sort of thing. They change the state of the system. Okay. So statements are commands. You can think of them kind of as a command. Do this, perform this thing, undertake this action. Okay. So they might change the value of a variable, return a value of a variable, call a method, return a value from a function, perform a sequence of statements some number of times based on some condition, perform a sequence of statements. And statements are found a lot in any language too. A huge amount, just like expressions. They're found in different places though. Where did we see statements? So, early on in this class, and for people earlier, I say, oh, you got to insert some Java code there, or you can insert some Java code here. But I'm playing fast and loose, because sometimes the Java code you insert are expressions. Sometimes they're statements. Expressions, I think, hopefully people here should be fairly comfortable with the idea of an expression, because it's kind of like the same expressions you put into a spreadsheet. This cell equals that, so equals that. That's the idea. It's some calculation, some formula. It's much like we do in events and system dynamics modeling. And with statements, we're dealing with things that accomplish things. And we've seen lots of statements in AnyLogic in a few days. Could anyone give me examples of where to look to find statements here? Where would I put statements? Where is it asking for statements? Where can I easily place these statements to do things? Yes. Okay. So we're in a transition. Do you place a statement here? No, that's an expression. It computes an action. It does something at that point. It accomplishes something. It's an action. It undertakes some action. So that's a great place where you put a statement. Another one was where? Where here? Entry action, exit action. Those are all places you can put it. But these things, ladies and gentlemen, are legion. If you go to person, you'll find that there's startup code under general for person. So you see there's startup code. That's an action. It's asking for statements, things to do there. It says, what do you want me to do here? When this person gets created, what do you want me to do up front? And if you don't put anything there, fine. You didn't do anything special. But you can put lots of things there. But don't go put expressions there. A lot of expressions won't serve any purpose. Oh, compute a value. Okay, compute a value for you, but it doesn't get used. Here you put statements. You put things to do. And what confuses us a little bit is that there are some expressions that like call off to a function that does something. So it's not quite as black and white as in portraying it. But generally speaking, well, you're always going to be putting statements here. You're not going to just put an expression. It's always going to be a statement. Okay, and so those are examples of statements. Let me ask this. This is a little quiz for you. So here's color. Here's an initial value. What goes there? Is that a statement or an expression? It's an expression. It computes a value. Expressions compute values. That's the purpose in life. Compute values. A statement does something. So you don't put a statement for the initial value. You put an expression for the initial value. So you passed the quiz. Similarly in main, there's startup code for main. Oh look, there's a statement. What does that statement do? I actually put this in. What does that statement do? Loops through each person in the population and performs some intervention on that person. This intervention needs some information who to intervene on, and I pass it some information about P, and it goes off and it does the appropriate thing. Okay, this is startup code for main. So main comes into existence, the world is fresh, and it undertakes an intervention as specified by the scenario. That's more advanced. We'll see that.
So when you say you pass information to P, what does that actually mean?
What I mean is, I give it, so this is a call to a function or a method. It's some code that performs some task. And in order to do its task, it needs some information. It's kind of like, you know, you could tell me something like, Sarah, you could tell me, like, Nate, could you go to your office, Sarah's office, to check if there's someone waiting for you there? I could say, yeah, I could do that, but I need to know some information, so I need to know where your office is located. If you tell me your office, I can go do that. If you could tell me where your office is located, you can do that. Similarly, for functions, we'll be talking about this tomorrow. For functions, the function, when we declare a function, when we declare a method, we say, what information do you need to provide it for it to do its job? And maybe what it needs here is, for the intervention to do its job, it needs to know who to intervene on, like who to affect. And so, in order for it to do its contract, it's part of the contract, in order for it to accomplish its purpose in life, it needs a person on whom to intervene.
So
okay?
I can send you to the grocery store, but I need to give you a list.
Exactly.
Got it.
And we saw this actually a lot in certain places. So, for example, maybe well, by the way, another place we see. Well, okay, this is actually a nice quiz. Well, the other one was nice too. But this is even nicer. Okay, so these are the dynamic properties of oval. So here's a quiz for you. Radius x, what do I put there? Is that a statement or an expression? Expression. It computes a value. It needs a value here. It needs some value for the radius. You need to give it a value. So an expression computes a value. So it's happy with that. Radius-wise, same thing. Replication, number of replicates that it has. Is that a statement or expression? Expression, actually, because it's the number of copies. Visible. Is it visible or not? Is that expression or statement? It needs to be a Boolean expression, like if my income is above $30,000, then it'll be like income greater than $30,000. That might make me visible or something, or income less than 30,000, make only people below an income threshold visible. X, Y, expression, fill color, expression. This expression is just a reference to the whatever value is in this variable is used as the value of color. So this color refers to some particular color. It's a reference to that color up there, and whatever color that is, we use this fill color. Okay, and the same thing is true for all of these. How about this guy? Statement. Man, good going. So that's a statement. This is a statement. You can just smell it in a couple ways. First of all, on click, it expects you to do something on click. It's not looking for a value. It's looking for you to accomplish something. The second thing is there's a semicolon there. And that semicolon indicates for sure this is a statement. It's a statement. When you see a semicolon, that finishes a statement. That's how Java finishes a statement in. Put a semicolon. Okay. So this is actually accomplishing something. It's doing something. It's changing something. In this case, it's sending a message to myself saying I'm infected. Okay. So those are examples of statements. Eh? So the answer is sometimes AnyLogic fills them in automatically for you, like semicolon. You can still put it there, but it will fill it in automatically, so you don't have to put it there? Oh, I dislike it because I like consistency. Consistency is a virtue. No matter what Bertolt Brecht said. So consistency is really makes it conceptually clear to people what's going on. So having a semicolon is it's a good thing. Put it in, that's expected, or where you use statements and you be in fun shape. Can you have a semicolon after a statement? Like, could you have a semicolon finishing a statement? The fact is that there are certain, and I don't want to get people confused, but there are cases where an entire statement is an expression. I told you before, foo equals 1 is an expression, computes a value, but it's also, you could follow it by semicolon. A statement could just be an expression, but most expressions are kind of useless to it. You could say A, but it doesn't do anything. It's just a value. And actually, we won't even bother with it. That's useless. It's useless. This is an expression, but it actually accomplishes something. It changes foo, and it'll actually, that's a real statement. And similarly, A++ is a statement. This is not a grade. This is not a mark. This says increment A by 1. That's a statement. It's also this part of it is an expression, but it's an expression that does something. So it sort of qualifies as being that's a sort of self-respecting statement. But yes, you can follow an expression by a statement, but that's just because that all expressions can be statements if they're followed by a semicolon. It's just certain of them are meaningful in the sense that they do something. Does that make sense? It's kind of so a statement. The job of an expression in life is to compute a value, but some of them have side effects. So all expressions compute values, but some have side effects that change them. That's almost true. There are actually some expressions. That basically what I said is almost true. Okay. I just don't want to get you too confused because there's one exception. You could call off to a method that doesn't return a particular value, and that's still called an expression. But don't let me get you. Yeah.
I guess I'm just trying to figure out.
Sure.
The patterns.
The pattern is if you see semicolons a statement,
Okay.
and if you're writing a statement, put a semicolon, and there are tons of places you use expressions, and do not put semicolons there, it will freak out. What would happen if I put a semicolon at a place where it doesn't expect it? Let's suppose right here, for this transition, for the rate, I put a semicolon. What do you think would happen? First of all, let's make sure it's in compile rate. Yeah, it's a happy camper. Okay, suppose I were to put a semicolon there. Would it be a happy camper? Oh, no. Well, okay, so let's see what's going on. I know exactly what's going on because it happens to be at the end. It happens to be at the end of a statement anyway, so it allows it.
Does it just not care? Is it ignoring it?
It's just it's substituting it in directly, and it so happens that at a place where it doesn't do any harm, which is so I picked a bad place to show you. It sort of is a case where it happens not to matter. It happens not to do any harm. It was just returning something anyway, and so it just said, oh, there's an extra semicolon here. It doesn't matter because it's at the end of the statement anyway. But there certainly are many cases where it will just freak out. I don't know about it. Substituting the middle of something, and suddenly you have a semicolon in the middle of another expression, and it doesn't know what to do.
So I was at
Yeah.
and somebody asked a question kind of like this. And someone at the workshop said that in any logic, if there is the length of colon has a colon, that indicates you either do or don't use a semicolon and opposite. Is that true? So some of them have colons after the word, like X colon, Y colon, Z colon, and others do not.
That's interesting. You know what that could be? I've never noticed that. Maybe it's just because I didn't read the manual close enough. So I'll I'll ask about that. That could be a pattern they try to adhere to, in which case it would be a great rule of thumb.
The on-click had a
Then the rule is false. Either that or they were sloppy. So on-click is definitely a statement, unquestionably. You got to do something there. Well, okay. Okay, on-click, you do something there, but it's true that I think it also lets you return a value from there. I think it wraps it up. Yeah, look at this. See, it says like return true to stop further processing, but that's still this is actually a, if I do return true, this is still a statement. These are all statements. You're going to see them in full glory in just a minute. These are statements. So I can't just put a value by itself without a, it wouldn't really, it is true that I need a return of something. So I need to put a statement there. Let's go see where this goes. This code goes, yeah, this code goes here. So we're inside an if statement. If I went here and so I just turned this and I tried building it, and it's all a happy camper. But watch this. Let's suppose I just put a value here. Let's suppose I put true. I don't know, true. If I put this, I suspect, yes, it's unhappy. It's going to be a grimly unhappy camper. Why is it unhappy? Well, let's oh, here, I'm in this one, sorry. Okay, so this is what it's unhappy about. It doesn't know, it says it's a syntax error. And what that means is it can't parse it. It doesn't know what to make of it. It doesn't know what you mean by just having that value there. So if that's what was said, that you could just insert an expression there, that is not the case, because this is clearly a case where it doesn't know what to do, and if you double click on it, it takes you right there. Oh, it should take you right there. Yeah, here we go, back to the OFL. Right there. So yeah, no, you definitely need a statement there. Okay. So send infection true. Okay, so let's talk about the set of statements here. What are these things we put in? The things that do something. If, for, while, try, catch, find, and throw. These are key ones you're going to want to know. These ones get more advanced. Well, we said expressions can be statements. You just follow them by a semicolon, and they can be a statement then. And normally you would do that for an assignment, or A++, or foo equals 1, or A dot connect to B would be a call to a function. That's its expression, but it's a statement. And then you can put things in parentheses. So here's a for statement. For statements iterate over something. So here, this is the most basic sort of form. You say, have a variable I that goes from 0 to 100, and it gets incremented by 1 each time. See this I++, remember that? Increment by 1. Each time it gets, so it initializes it. It tests if this is true. If not, it leaves. It performs the statement, and then it does this. And so this is I equals I+1. And then it goes and tests it again. Is it true? If it's not true, it leaves. Otherwise, it executes it and increments it. Comes back around, tests it again. If this thing is false, this I is less than 0, it leaves. Otherwise, it executes it and increments it by 1. Okay, so this goes from 0 to 999. And for each of them, it's executing the statement, which may involve I, it may depend on I in some way. So here, we're doing this over and over and over again. This, ladies and gentlemen, is called a loop. I'll share with you a personal story that Charles heard before. So, when I was a young kid, was in, I think I started getting fascinated by computers and things in 4th grade or something like that, or 3rd grade. But we didn't really have computers around in those days. Computers were big things that were stored in special places. But I could get a hold of a calculator. I got a hold of a programmable calculator. I spent a lot of my summer camp programming this calculator to do various calculations. But anyway, in a sort of assembly language type thing, but sort of very low level thing. But then I heard that there was going to be a course taught at our high school for continuing education students, predominantly people like in their 50s, 40s, to learn, to interact with computers, and to work with computers. So I signed up for this course. I think by that time I was in 5th grade. And I spent this course sort of over the years writing other programs for them and so on. I really wasn't paying attention to material. And then I heard that there was going to be a final exam. And so I got kind of worried. And so they had us all lined up in rows, and I was surrounded by all these really old people. Some of them were probably old in the sense they were in their 20s. And I was, little kid, yeah. Surrounded by all these, well, it seemed like a professor. The instructor was pacing back and forth, preparing us for the exam, helping to quiz us with little questions. And so he was asking, how would you, increase the value of a variable? Oh, you'd say, a variable A, you'd say, if you want to increase it by 10, you'd say A equals A plus 10, or something like that. This is in Fortran. So he was walking back and forth. And then he said, so suppose you wanted to do something 100 times, one after the other after the other. What would you use to do that? What sort of statement would you use to do it? And he looked at me. I don't know. He said, I'll give you a hint. It has an L, 2 O's, and a P. And I said, cool? He probably wrote me off at that point. Probably chuckling about that for years later. For all I know, he may now be chuckling about it. I certainly am. So I pulled myself up since that point. So this, ladies and gentlemen, is a loop, not a pool. And this is the second for loop. So here we have some collection. This could be our population. Did you notice that earlier? Did you see that earlier? Actually, a fine example of it. So let me get this going again. But did you see where we had this? Is it still O? It's still causing problems. But this is this is a case where we're using that. So we're going over the entire population. Each person P in the population in turn, we're doing something with that person P. Maybe this could be P dot connect to person 1 in the population, or it could be P dot it could be trace ln of P. In other words, P's name is such and such, something along those lines. Okay. So this is the form that you'll sometimes see for loops that loop over collections here.
I have a question on that, if you don't mind.
Sure.
If you get a concurrent modification exception on an iterator for loop, what does that generally mean?
It means that you should insert a synchronization routine because there's probably some other statement that's executing another thread, such as the visualization thread or something that's conflicting with this.
Okay.
So there needs to be some mutex, some mutual exclusion component that is inserted to make sure that you're not accessing the same data from 2 different places.
Okay, that's what I figured. We might need to help the one of the groups they're having the big group from University of Buffalo,
Yes.
the big model.
Yeah.
They're trying to do something in there whenever they're doing on-click,
Okay.
and
Yeah.
for that it's supposed to basically remove stuff and it's throwing it there. And
Okay.
I found that very interesting. So if you could look at that.
So the person you get is Dylan.
Okay.
Dylan is a multi-thread programmer par excellence,
Got it.
and he'd be a great person to say on it.
Okay. Good.
So you know who Dylan is?
Yes, I know exactly who Dylan is.
Okay, yeah. Go and be fruitful. Okay, so here we're looping over some collection. In this case, we're looping over looping over a population. For each successive person in the population, we're calling that person P, and we're doing something with them. Okay. In case this is confusing, this could be, P dot connect to, population dot get 0. This would connect each person in the population to the very first person in the population.
Does that P have to be assigned someplace else already?
No, no. This is so-called binding P. So this is getting it's creating a little variable where each successive value, each successive person in the population is named P. Okay. Okay. Yeah. Okay. So this would be an example of some code. This is more code than I like to see. I don't like to see much code. If I have a lot of code, it's assigned. It needs to be parceled up into little pieces that each have a function associated with it. But this is a sort of about as long as it gets, this little bit, without me feeling uncomfortable. So here we have a for loop. It's iterating over each successive angle of a set of angles. And here we have a set of distances that are being examined. And if it's more than a certain sort of distance, then it's going to go to another angle, and then it's calculating some things in here. One thing I'd like you to notice the indentation. Each of these statements can contain sub-statements within it. A for statement contains statements within it, and by convention, those are indented. If you do not indent, you're in extreme danger of misunderstanding. Indentation is one of the prime ways we communicate the structure of code. And so, if you have a statement and something lives inside of it, indent that thing, okay, as a rule. And it communicates, okay, all this stuff is inside this stuff is inside that one. In other words, for each iteration of this guy, with A being from 0 to 2 times pi by increments of pi over 16, we're going to be executing this whole stuff, and then for each of those things, we're going to be executing in here. Okay. So that's a for statement. An if statement, by contrast, tests some condition. Okay. So here it's testing. Testing, say, is A greater than 4? Is D less than D min? Some value is X greater than or equal to 0 and less than or equal to 500? If so, do this. Otherwise, do that. Okay. Now, you also have versions of it which only have the consequent, not the alternative. In other words, if this condition is true, do this. Otherwise, it just kind of falls through to whatever's after that. So it does this only under this certain condition being true. So this is very, very common to perform different actions based on whether this condition is true. I want to contrast that to that ternary operator we saw earlier, where we have a condition. I called it a predicate earlier, but it's a condition. So we have some condition, and then we have a question mark, A or B. Here, we're not asking it to do something. We're just asking it to return the value from this expression, or the value from this expression. So here, we're getting back the value from it. Here, we're actually telling it, if this thing is true, do this thing, otherwise do that thing. There's no value that results from this. It just does this, or it does that. Maybe this thing is a while loop, or maybe it's some complex thing that condition that it does. But here it's different. There we're returning a value depending on the condition, which value depends on the condition. Here we're doing something different depending on the condition. Does that make sense to people? Okay. So that's if statements. So for example here, this is from the wandering elephants model, which was the initial inspiration for Gregor's team. So here, if they're thirsty and they're by water, then they drink. If they're in a bunch of vegetation, then they destroy the vegetation. And those are some examples of ifs. There's other ifs you could like. If the distance is greater than a certain thing, then.
Do you have to define the vegetation and the water first?
Yeah, the vegetation and water actually defined it's not shown here.
No, but it was the definition of the altitude defined the water, so your, any
Right.
altitude there is less than zero, that may get water in that model.
That's right. So there's altitude calculated by the model up front. And this is a so-called array. It's a two-dimensional array, meaning it's not just sort of along one dimension, it sort of has rows and columns, and sort of like a matrix here. And here we have a two-dimensional array of altitude that shows for a given square, maybe it's 16 meters by 16 meters or something like that. What's the altitude of it? And they assume that sort of the reference altitude is zero or water. Or that's the sort of altitude of the water table.
It seems to be though, would be way easier to understand if that were a function that said is one.
Exactly. Precisely. And that's, ladies and gentlemen, that's the name of the game. And that's what we do for our models where possible. We sort of bind these things up and put them, and then you say it's water. Because I can almost guarantee you this appears at several places in this
Oh,
model.
it does, and it's horrible if
Quite a
you
few.
need to change it.
If you have to go change it so water starts at a higher level or a different level, or there's a different rule for water, it's a big mess. So if you have is water, it's both clear to communicate and it's more flexible. You can change it much more easily because it's defined in one place.
Can you do that, say, is human,
Yes.
and that if near human,
Yes.
like,
Absolutely. Absolutely. Yeah, no question. Yeah, yeah. That would be a clean way to do it. And in fact, some of the things that we've done in class, like testing, are they in the infected state in determining what color to show? You know, I prefer to have a method called is infected. And that allows us to have maybe three infected states, you know, an asymptomatic and a symptomatic infection. And both of them would be, yes, they're infected, you know. And yet, so we can flexibly evolve kind of the state chart without worrying that it's going to break lots of our code, because we have these nice methods. You know, here's a complex condition. What is, ladies and gentlemen, what is this? Can anyone interpret for me what this does? This is an if statement. I know it's hard to see here with the light coming in.
is it if x is less than the area or x is greater than or equal to 500?
Yeah.
Or y is, it's like an eye subject.
Yeah, I'm sorry. I wish I could bring it in, but I'm not that strong.
So it's just lots of or statements, and then I guess it will have, you know, if all those conditions are fulfilled, then
Yeah. So basically what this is saying is, if you're outside of the bounds, this is why this is so
Or you're
confusing.
in water.
That's awful.
Or you're in water, do this sort of,
Yeah.
do
Stop.
this sort of thing. In other words,
Stop.
try a new heading, stop where you're going, and recalculate.
Yeah.
Like, oh, we must not be in Kansas anymore, you know,
Yeah.
let's go a different direction. But the point is, you can string together these things with long ors, but the eyes glaze over, even if it's not an eyesight test, even if you were close in. I mean, basically, it takes time to piece together what is being, what's the essence of what's being sought here. What are you trying to do here is something that needs some thought, right? And really be much clearer if you said, you know, if not is in bounds of C and of X and Y, or is water of C and R, you know, then do this. It would just be much clearer. Because again, these are conditions which occur a lot. Folks, do you know how fragile this is to put like 500 there? If they extended the space, you know, to make it 1,000, because you want to make it big, suddenly all your code breaks. And there's just no excuse for that in terms of a model you send out there, because this is really, really easy to just put in something. Even if you wanted to have this expression like that, you'd have x greater than or equal to, you know, this.get main.space width or something like that.
In any logic, can
Yeah.
you go into like the base underlying code and search and replace that all those 500s, or do you have to go
You
through
can.
each of those pieces and do it?
Oh,
Do you have to navigate through each of those frames and do it, or can you actually, I didn't think you could edit the underlying.
You can. Yeah. You got to go through each of them. I mean, it's not horrible, but the worst. I mean,
Yes, I would
replacing
guess-
500 at 20 different places it doesn't sound perhaps so bad, but it's painful. But what's worse, ladies and gentlemen, is the thing that you'll often see where someone has put 499 somewhere because it's 500 minus 1 or something like that, or they put 501. Believe me, this occurs a lot. It's like, slight things, or they'll put 5,000 because it's 500 times 10, and you search for, or 500 times 20, they put 10,000, and you don't really realize that that's logically linked to 500. So you go through and replace all the 500s, but you didn't replace the 501, or you didn't replace the 10,000, and suddenly the code breaks because there's been an implicit dependence on it that's not obvious textually, and you missed it when you did the search and replace or whatever. And that's why this is so dangerous. That's why you got to be sort of careful. A lot of this is sort of thinking, how could things go wrong? What could change? And let me guard myself against a change by giving it a nice name. And there's really not a lot of downsides to it. It takes a little bit of time, but it's just cleaner. Just from a hygienic perspective, it's just much cleaner, and it's much easier to evolve as well.
Could you put values somewhere in the interface and pull from there? So like you
Yes.
get a slider or something, you can pull values
Yes, you
from the
can.
slider?
Yes, you can do that, and the thing you got to be careful about there is sometimes the interface evolves quicker than the model does, and so that slider may come and go. Maybe you'll change it from a slider to a drop down. Maybe
Just
you'll
something
change
nice
it.
to have it in perfect.
Sometimes it's nice to have, if you're going to do that, you have a method that's like my width or something like that, and then that gets it from wherever it needs to be.
Okay,
Cool. Yeah.
yeah.
That makes sense. Yeah.
When you say method,
Yeah.
can you reiterate what that, when you specifically refer to, is that when you're just
Oh, so when I talk about a method, I mean a function that is defined in some other person or defined in me.
So a function, so you copy it using
You can put it.
functions?
You can put it in an explicit function here, like that. That's one option. You can also, in any logic, define functions, so-called methods, separately. A method is just a function in a class, okay, that operates on a class, and so you could associate persons with another function as well. Good luck. I'm glad she's taking care of you.
Thank you. Yeah, no, it's really good.
Good.
Appreciate it.
Good luck there. So we can put things at functions like, you'll notice they have carved out functions for things like heading. These are not all named functions, but they're at least functions. Heading random or heading to water. I think that means like head to water, and that. So you can call that, and it takes care of the logic for it, which is good. I mean, that's nice that it kind of they've wrapped up some functionality. But in general, you want functions that are like is infected, or is dead, or has child, or is adult, or whatever. Those are kind of nice things to wrap up as tests, and then maybe also functions for things like connect to mother, or perform birth, or something like that. And you'll see examples of that in some of the example models that I've given. So great question. Any other questions on this? Okay. So let's further talk about this. There's also something called a while loop, which occurs in two forms. A while where the test is at the top, or a do while, which where the test occurs at the bottom of the loop. So here's an example of a do while. So you say, do this stuff while this condition is true. Alternatively, you could say while this condition, you could say while some condition is true, do this stuff. So you can put the while at the top of it, or you could say do while this thing is true. Either one case you're testing it when it first comes into it, the other you're testing after it's done it once. Okay, and you can do either. Okay, now this is a useful thing. Switch and case statements. These go together. Cases are within a switch statement. Okay, so basically, they're conditional. They're kind of like an if, but they're kind of like a multi-way if. So we have a binomial distribution and a multinomial, which handles more cases in probability and statistics. Here we have an if statement that handles two cases, but a switch statement can handle as many cases as you have, as you want. So you could say like switch on the ethnicity of this person, and then you have a case to handle a First Nations person, a case to handle a Caucasian, a case to handle immigrants from East Asia, immigrants from South Asia, what have you. And each of them can do kind of a different thing, return a different value. Maybe it's a switch statement that based on the person's, I wanted to show you this, but I didn't want to scare you. Based on a person's current state, it returns a color. So switch on the current state. Am I susceptible? If so, return green. Am I infected? Asymptomatic infected? Return purple. Am I symptomatically infected? Return a red. Am I, vaccinated? Return a pink. Am I recovered? Return a green or whatever. And so there it can handle each of these cases. Boom, nice. So I don't know. Here's an example of one of my example models. So I ask, okay, what's the network file type? If it's a PIAC file, do this certain thing. If it's a connectivity matrix, do this other thing. Otherwise, say, I don't know how to handle this. This is an example of a switch in case statement. So it handles, and this can be arbitrarily many cases, many as you want. So one option is very beautiful for things. You could have all these state charts, and you have long sets of states and all that sort of stuff. But you could have get color. Nothing. Get color. Pump. And every time you add a state, you could just go in and add a case to it or whatever. You could have it consider this state chart and that state chart and do custom things. But in any case, a switch would sort of allow you to consider a bunch of cases, and they could each return appropriate colors. And then you don't put directly into the dynamic properties and that fill these complex expressions. You just put in a nice function, and you just call it. You say get color. Boom, done. Sometimes within these things, wherever you expect a statement, like inside it, or inside a while statement, or inside a do while, sometimes you may have a longer sort of body of code. So, for example, this do has a begin bracket, end bracket here, curly brackets. And those curly brackets mean that there's, inside of it, there's code, okay? So here's a bunch of statements, one after the other. This is called a compound statement. It's one statement after the other, okay? So simulate those curly brackets here, curly brackets down here, those are matched. So all this code is within kind of that. That's a statement. It's a one long statement. It's surrounded by these curly brackets, which kind of mean a compound statements here. It can have as many statements within it as you, or a composite statement. Okay. Right. So I'm just keeping an eye on the time here. I think I'll sort of leave that. Okay, right. So sometimes things go wrong in the execution of code. Sometimes bad things happen. What bad things happen? Where do we see something bad happen? We saw something bad happen. In fact, I deliberately made something bad happen. I tried to access mother, print out mother's name or whatever, when I didn't have a mother, and it threw what's called a null pointer exception, which is one of the most fearsome security expressions around for beginners. So things can go wrong in code. Bad things can happen. It can't do its job. And it throws what's called an exception if that happens. It says, some exception happened. I can't do my job. Help me. Tell me what to do. Fix me up. And so it's kind of like it's going to go to the emergency room or something. And it stops the normal processing of code. It goes up to some context where someone can help it. Okay. And we can actually put in place things to help it. And that's what this whole try-catch thing is. This is fairly advanced. I don't think you'll need this anytime soon with working with any logic. But if you start to kind of use any logic with some additional things like writing to files or whatever, other Java libraries, you may see this. So here, you say, try this code, and if something goes wrong, catch it and catch this certain type of thing, for example, and do this other thing instead. Okay? So if something bad happens here, warn the user they weren't able to complete the job, and get out of there. Print a message, or clean up, close the file, or remove the file that you were creating, or whatever. Occasionally you'll see this, and sometimes in fact Java will refuse to let you just put this try block by itself. It'll say you need a try around it because there's an exception thrown here, and you gotta fix it. It's like you gotta wipe your butt, if you're here. You're gonna do this thing, something could go wrong during it, and you gotta clean up after yourself. It's kind of your mom. Don't you leave that mess around. Something could go wrong here, and you got to be a responsible adult. If something could go wrong here, like the file can't be found, you got to be able to handle that case. Or if it's unable to write to that file because the disk is full, you got to be able to handle that case. And so you say, okay, I'll put this try thing around it, and if the disk is full, I'll print out an apology to the user, and that's it. And it'll be happy with that. Just sort of giving some measure of attention to the fact that things could go wrong. Why does it force you to do that in Java sometimes? It's kind of a pain. Well, it's the same good reason that mothers do, I suppose. That if they don't put that pressure on you, that you'll sometimes be sloppy, you'll sometimes be loosey-goosey, and you won't handle this, and things will go wrong, and you'll regret it later. So your model will sometimes die, without any indication that something went wrong. It'll just explode in someone, and it'll give you a bad name, or they'll think your model just doesn't work at all. So here, it provides you a way of sort of being responsible, cleaning up after yourself, and forces you to really deal with the fact that sometimes things don't work out as you want them to. So here, it's often the case when we're dealing with things like writing a file, trying to read a file, trying to get a file. Sometimes things are wrong, and all too often, folks, the bugs in software are caused by failure to really deal with that sort of thing well. Okay, so here, for example, is a case where we try to sort of parse some file in a certain PIAC format. So I try to read in a PIAC file, and I'm counting on this file observing the PIAC format. I'm counting on it being a valid PIAC file, but maybe it's not. Maybe there's something wrong with this file. Maybe someone gave it a half file, or they misunderstood and they don't know what a real file is, and they give me a file that's not truly legitimate PIAC file. I have to be able to handle that. So I try to do this thing, and this thing that I use to do it, this is in the example models I give you, this thing that I use to do it, I use some Java library to go parse files, to go read in things really easily. And that's great, but one of the things that will complain is I can't parse as a number this thing you told me was a number. So maybe in my PIAC file, normally PIAC has, connection 1, 2, 3, 4, 5, 6, and maybe one of them, instead of saying 3, it says, 3E or something like that, or 3G or something like that. It's some typo in there. And then it will say, I don't know what to do. And you have to be able to handle it. And so, I print out a message, could not pass this certain line. And I give the line number. And I say 2 numbers separated by white space we're expecting, and I describe what they are. So I provide useful information to the user to say, go clean this up. I couldn't make heads or tails of what you gave me. This is the line that confused me. Go fix it up. So that's what this is. This is fairly advanced, but just realize if you start to use external Java libraries, it may say I can't do this because there's an exception, and then you just wrap a try catch around it and you do something to sort of say sorry, we couldn't do our task. Okay, so those are Java statements. Time is fleeting. If there's a few minutes for questions, I'd be glad to answer them. But otherwise, tomorrow we'll go on to some additional stuff. So questions on this? Yes.
Can you, are you gonna post these lectures?
Yes, thank you, thank you. So first of all, I'll post this to YouTube and, but more to the point, I'll see, before I leave tonight, I'll try to get these PDFs, to the shared O drive.
There's, the slides are on the website though.
They, versions of them,
Yeah, they're a little bit
Yeah.
different, but they're pretty close.
they're pretty close. Yeah, that's right. Yeah, but I'll make sure that this gets on YouTube, hopefully. Okay?
I probably won't open it.
Okay, other questions? Other questions? So maybe you folks could tell me, so I had two different ways of sort of approaching this. One is to sort of give a little lectures on, different statements and give you an introduction to them. Another would be to actually like sit down and look at some code, like show you some code and say, what about this is possible to do? We've had a brief introduction. Here's some code for you to look at. Maybe it's code from this model or whatever, and say, okay, what about this is still confusing? What things are still throwing you off? What things do you need to understand here still? Or you can bring in your models and say, look, I'm missing this or that. Would that be a useful thing to do for say half an hour or something like that, or an hour? Yeah.
Going through this, generally is great, but once we've gone through that basis,
Uh-huh.
and I think at that point we use code instead of looking at it and trying to see.
Sure. The important thing to realize, a very important thing to realize is here, it's not going to be so helpful to look at just annual Java code. Any logic, you're not going to need all of Java. And I'm really restricting what I'm covering to try to cover what you need to operate in any logic. So my thought would be to look at actual models, just some models like we use as examples, etc. And really kind of get you to face the fears. Okay, what's really, like how bad does it get? And get a chance to expose anything I'm forgetting to cover.
I think that would be really helpful, because I find when we go through this and somebody's already done it,
Yeah.
that's great, and then I go to do it. Put this, I know that I want my agent to do this, I don't know what kind of statements I need to write to get the agent to do that.
Right.
So that type of, like, if you want your agent to do this, you need to write this type of would be really helpful.
So that's great. I think what we're dealing with here, what we're pointing to here, is at the heart of the primary barrier to use of any logic and by extension agent-based modeling. And the AnyLogic folks know that, and we are trying to come up with all sorts of ways to ease this barrier, because Andre, the CEO of AnyLogic, put it most clearly to me. He said, the primary barrier to use of AnyLogic is this sort of box here. People come back from boot camp, they come back from training or whatever. They've seen these great models, they have excited ideas, and then they go to create a model, and the box just stares at them, and they don't know what to put there. They don't know how to describe things. And so we're looking actually for ways that we could maybe like have suggestions here, intelligent, maybe like give you examples from many other models, like what did someone put here? Or maybe there's some way you could say like, what I want to do is something to do with the population, and it would say like, okay, these are sort of common expressions where you can manipulate the population, or common statements that would use the population. Or maybe we have links to certain like Khan Academy like videos that are like 3 minutes long of relevant links for what you might put here, something along those things.
Is there any logic dictionary that doesn't have sort of a dictionary type website where you can look up commands and stuff like that?
Well,
I really wish they did.
so there's the help where you can look up particular things, and that is a fair bit of information. It's not as good as it would like, not really as good. There's also the big book of AnyLogic, which is being put together.
This is where I'd like, well, with this
Yeah.
method, where I'd like to issue a shout out to that logo. You push F1 when
Yeah.
you're in a command, and you go, whoop, here's this dictionary entry. So if you had a
You
specific
can't actually do
dictionary
that.
where you click it and said destroy code means this.
Go to help?
Yep.
No, not help. I think it's view.
Okay. Yep.
Help. Click the help thing on.
Yep. Yeah.
Then if you're actually in an object,
Yeah,
I think it pulls up the properties of that object.
Yeah, that's exactly.
yeah,
Okay, I've never used it, but you know, I know that exists because again, real estate's at a premium with any logic, if you'll notice,
yeah,
particularly running at lower resolutions.
right. So this is good, and this will get, this helps. I actually wasn't aware of this. That's actually very nice. I think though that the other part is that creative part of like, how do I go from the description of what I want to do into kind of at an operation, so what I want to do to how to do it. Like what are the steps I'll need to go through. And I think we could do a much better job of at least giving examples or relevant material or links to videos or I'm talking really short videos or links to example models which also used this field or something like that that might be useful. Yeah, Carmel.
I mean, that's what I've spent a lot of time doing is going through the analog example model, going through the YouTube videos online,
Yeah.
and borrowing bits and pieces of code and trying to like find things that seem like they are similar to what I want, and then maybe tweaking it and but I still feel that this whole process
Yeah.
is part of the learning curve, and I don't know a fast way around it. I think that having this lecture stuff is great because it gives me a foundation, but it's not quite like me sitting in front of my model saying, okay, now I need to do this, because then I still get that feeling like, oh no, there's a big white box. How do I begin to approach doing this?
Yeah.
And that might just be part of learning computer language. I
Well,
don't know.
It maybe there's also, frankly, there may also be a role for mentorship or apprenticeship or something in the sense that doing pair modeling together with someone who is at a different skill level may give you sort of ahas about how do you think about it, how do you frame the issue, sort of how did you know that you need this, like there could be sharing of things there, and this is one of the things I'm hoping will come from the projects here a little bit from the TAs, people seeing the TAs perform, but what I'm hoping is that the TAs don't do everything, it's very important that TAs then see the other people do things, make suggestions for them. But I think we're addressing the biggest barrier, and so I would welcome all of you in the coming days, and include of course Saturday if you're here, to sort of provide suggestions about ways, just brainstorming about ways that we might really address this. And this could be in the boot camp, it could be online, it could be in software, built into any logic, any number of different ways. I'm totally open to it. But the broader training challenges and whatever we could bring to bear, whether it's conferences or boot camps or sort of online assistants that can be summoned, summon my TA, and they come or
Yeah, you have that. That's cool.
I think there needs to be some kind of practice, like, I don't want to say exercises, but exercises to go through to help me help myself think about that process.
Well, pardon me for just one second, because we have something that relates exactly to this. We were hoping by this boot camp, hoping is the operative word, to have all the exercises for the boot camp redone so right now they're very, very detailed. It's like do this, and that's great. And you learn some skills by doing that, no question. Sort of train at the level of training. What we really want to do them is to turn them instead into, undertake this task. And you have to think how to unpack them. Like, what are the steps you're going to need? And the idea is, and actually the TAs have done quite a bit towards this, sort of you have hints that you could click on, like, I need a hint on this side, and we'll expand in a little bit more detail. Try these sort of steps, but it's still the what you need to do, and you have to unpack it into the how. And at some point you may just say, well, let me see the solution. But in many cases, you're going to be going through that whole process of needing to, for yourself, formulate how to think about unpacking it into the how.
And I think that's, that is,
Okay, so maybe we could talk with the TAs about that, because this is probably gonna be a big push in coming weeks. And so if we could get your feedback, the feedback of anyone here, about what our ideas, we can present it like in a little bit more detail, they could show you, I think, some example or what have you, and then you could provide some feedback, oh, it would be even more helpful if you did this, or what have you. Yeah, but sorry.
Yeah. No, a couple things.
The bus is coming.
Right. So, one concept I want to let you know is that that's the number one feedback from any like this training course.